Okay, fantastic, and welcome to those of you who signed in for this afternoon, and I suppose morning, depending on where you are in the world. Webinar between CASLE, the Commonwealth Association of Land Economists and Surveyors, and the Institution of Surveyors Uganda. The president of CASLE, Joseph, is currently at the meeting physically in Kampala, in Uganda. There's been a two-day conference over there with several hundred delegates from all over sub-Saharan Africa and elsewhere. And I'm really delighted to be able to tie in to, I suppose, the end of the conference on this incredibly important subject about artificial intelligence. There's an enormous artificial intelligence global conference going on in the UK at the moment in Bletchley Park. Some experts from all over the world, and I know for many of us within surveying, it's a subject that is creating quite a lot of interest and also trepidation as it starts to affect our various areas of practice. So, our colleague Neil Sawney, head of construction, is going to kick us off with his presentation. Just get the screen up now. And I'm going to make him a presenter, which I think I already have. Are you ready, Anil?
I am. I'm going to share my screen. Okay, it's saying screen sharing is now paused. Okay, I hope now you can see my screen.
Not quite yet. I'm going to turn Patrick off on things so that, I think everybody can just see me at the moment. And we can see you now, Anil, as well.
Okay. I have now shared my screen. Can you confirm if you can see my screen?
Not just your face at the moment. Maybe we do that, and then.
How about now? Because I've turned off my video, so hopefully my screen shows up now. It shows on my side that I've no one sees your screen. Okay.
Okay. I have not got a clue what to do.
Sorry, folks, give us a minute to figure this out. We'll get started shortly. Sorry about the slight delay.
And Neil, it's Andrew. Do you want to just unshare and just share again and see whether, because you should see a red banner around whatever content you're sharing. It should allow you to choose either the whole screen or an active window.
So I have now, I'm going to click on show applications, and I'm now even moved to a PDF.
That's it. We can see you now.
Okay, so now at least a PDF is visible. Sorry about that. So I think we're going to get started. Is that okay?
That's great. Thanks, Anil. I'll go on mute.
Okay, thank you, James. Thanks, the conference organizers, for inviting us. I'm going to get the session started by very quickly giving you an overview of my views of AI when it meets construction. My name is Anil Sahani. I'm the head of knowledge and practice of construction at the RICS. I'm also the chair of the International Cost Management Standard Setting Committee. Over to my outline or an agenda for today. What better to let ChatGPT prepare the presentation? So that's what I did. I gave a prompt to ChatGPT to prepare an agenda for my presentation. So I said, list the 5 themes I should cover when introducing artificial intelligence to construction industry professionals. keep these in high level. So ChatGPT came back and said, okay, give an overview of AI, then applications, benefits and challenges, talk about data management and analysis, future trends and development. And then I have a professional subscription to ChatGPT 4 Plus, so I can have some add-ins. For example, a tool called Lucid, which is a diagramming tool. So I asked ChatGPT to create a simple diagram of the agenda as well. So you can see that it created a flow chart for the presentation. So I literally practiced what I'm going to share in terms of my presentation. And you can see to some extent, AI is already having an impact at the way we work and the way perhaps we also sometimes play. So let me see if I can go into full screen mode. That may be better, okay? So let's begin with an overview of AI. I'm mindful of the time, so I'm going to go a bit quickly here. When today you talk about AI, it's a very complex picture. You get words thrown at you like generative AI, large language models, foundation models, machine learning, deep learning, zero-shotting, fine-tuning, and hallucination, and so many other things, such as LoRa, the low-rank adaptation, RLHF, which is the reinforcement learning from human feedback. So it's very easy to get confused as to what we're really talking about. I wanted to start off with that, and this may not even be comprehensive. The types of things that one would see when we talk about AI. But AI, the definition itself is pretty straightforward. The father of AI, John McCarthy, coined this term and defines AI as the science and engineering, and I think it's also mathematics because it's heavily statistical inside working of an artificial intelligence engine. So he defined the science and engineering of the AI as the science and engineering of making intelligent machines, especially intelligent programs. So we all must recognize that at the end of the day, AI is a computer software. We, RICS, we did an insight paper in 2017 in which we defined AI as dedicated to the study of computer software capable of making intelligent decisions, reasoning, and problem solving. More recently, IBM uses this definition of any system capable of simulating human intelligence and thought processes. There are three levels of AI, taking again from a very broad perspective, what's called artificial narrow intelligence, general intelligence, and superintelligence. The artificial superintelligence is the scary bit, where we all hear on TV and podcasts and so on that one day AI is going to overtake us all and perhaps will be extinct. So that's the range of AI or type of AI which can surpass human intelligence and capability. We, I think, more or less are at the narrow intelligence where we can perform specific tasks or narrow range of tasks through AI at the human level. But moving towards GI, which is essentially natural language, solving complex problems, creating original art. You see many pilots or many open source tools available for artificial general intelligence. Now, there are different branches of AI. The most important one is obviously machine learning, in which deep learning, which is another sub-branch of machine learning, is taking hold these days with the help of ChatGPT, Bard, Llama, and other types of open source AI tools currently available to us. But then AI can also deal with knowledge-based systems, and most of us who are a bit older than others are aware of expert systems, which is a class of knowledge-based systems, computer vision, robotics, NLP, or natural language processing and optimization. There are various components of AI, as you such as learning, knowledge representation, and reasoning. I think this Outlook is causing problems. I'm trying to shut that down so we don't get more messages here. These are the various components of AI. Traditionally, AI was seen as artificial neural networks. So way back with the help of a student in 2001, we developed an artificial neural network for selecting cranes on a construction site. This model, which was based on a very simplistic artificial neural network with hidden layers, other summation layers, and output layers, we created and trained, validated, tested, and deployed a very simple ANN for crane selection. That was sort of the history of how AI began in construction and civil engineering, primarily focusing on the use of artificial neural networks, where you had both supervised, generally supervised, but somewhat unsupervised learning also. But things have significantly changed. A paper some of you may have already read came out in 2017 from the computer scientists. The title was very catchy, simple. Attention is all you need. That's the stage at which really ChatGPT and the likes of ChatGPT were born. The paper described a very high-level architecture of what is called a transformer, which you will see on the right-hand side of my slide. We're not expected to understand how this architecture works, but essentially what shifted was the way a neural network or artificial intelligence learns. Shifting from a very random approach to an attention-based approach led to the development of what's called GPTs, or generative pre-trained transformers. GPTs are what we are using now when we use ChatGPT or DALL-E or any similar tool available in the market. So from the previous 20 years of work in AI, this paper, I believe, changed how artificial intelligence was looked at after 2017, and that hugely shifted the way all sectors started looking at AI also. So that led to the development of this subdomain called generative AI, which is essentially a type of deep learning model, a neural network with lots of hidden layers that can generate. It can produce the next word in a sentence, essentially, which can generate high quality text, images, and other content based on the data they were trained on. That's a definition from IBM. So generative AIs created foundational models called transformers, which we today use for vision and audio, large language models such as ChatGPT or Plan-T, and code interpreters, which can help you develop or write code in Python or even analyze an Excel spreadsheet. So now many commercial and open source foundation models are available. So that's sort of a very quick and perhaps confusing introduction to AI. As presenters today, we thought we'll give you a quick look at what's happening in AI generally before I present an overview of application of AI in construction. Then we'll have follow-on presentations that'll go to probably more use case specific before Andrew Knight, my colleague, will sort of connect AI to property and land also. So let's look at some examples of the current use of AI in construction. One, the traditional uses in construction of AI were, I think the grandfather of all tools in our sector has been generative or parametric design, where perhaps you can use authoring tools to create new building designs using what's called parameters. So sort of artificial intelligence, sort of generative in that if you changed a parameter for this room, it could redesign itself and move doors, windows, and other openings accordingly. So that was the primary purpose of the use of AI early on in design stage. We, as I shared with you on an earlier slide, ANNs, or artificial neural networks, were another major chunk of use of AI in decision making. And then several applications of genetic algorithms in optimization in our sector were also used. But now with the advancement, especially in generative AI and increase in the availability of data, there are some emerging use cases that I'm going to discuss here beyond what you've already seen in the literature and seen applied in our domain. One of the major use cases in my mind is reading of construction documentations. As you know, a typical construction project, before even it gets into construction, is going to have a humongous set of data or documentation. So you'll have PDF documents of the contract, of the general conditions, the special conditions, perhaps construction drawings, site investigation reports, and a whole host of other project-related documentation. People are now applying large language models, such as ChatGPT, to classify, summarize, identify issues, and review those documentation in a much, much faster fashion. For example, you can import into a large language model your specifications of construction products and materials that are going to be used, and quickly do a review and see if there is anything missing, if there are any discrepancies. It really then starts assisting the estimator, perhaps the quantity surveyor, the project manager, use their experience and expertise, but then also supplement that with these AI tools to do document analysis. That's one very solid growing area of application of AI in construction. You will see many commercial tools available that can do this. The next set of use cases are related to project planning, controls, and risk management. Through generative AI and other AI techniques, you can now automate the process of schedule development. So you can provide project information, you can build schedules, optimize schedules, manage constraints, assess the variance, especially from a project controls point of view, suggest corrective actions, and guide the project team as the project executes using historical information. Again, several examples of startups that are beginning to use this. Even the established players are now launching AI tools which can sit on top of a scheduling software and can guide a project team to more holistically and carefully analyze their plans, do controls, and also be able to manage risks. So AI can be used to look at historical data, compare it with your current project, and predict potential risks and issues, and help you with proactive risk management. You can use AI today for cost estimation and budgeting. I think it's going to be difficult to read on the screen, but last night, as I was preparing, I put in a prompt into ChatGPT saying, can you please provide a table that shows the work breakdown structure in column 1, activity description in column 2, duration in 3, average cost in 4, predecessor in 5, also add planned start date, planned finish date of these activities, assuming today's start date of the project. I don't need any explanation, just give me the table. ChatGPT thinks, comes back, and in shillings, it is giving me average costs of site preparation, clearing and grubbing, grading and compaction. So it came up with a standard set of activities, and there's the schedule of those activities with an average cost and a duration. So I don't know how bad this estimate is, but it claims that these are average costs in Kampala in shillings. But the point is, today you can get assistance from AI to develop cost estimates. Next thing I did was I went to the Copilot, which is a Microsoft's tool for using large language models. In fact, uploaded a very simple plan, as you can see on the right-hand side, of a single-family home. And I asked to analyze this plan, try to figure out the dimensions, and asked it to give me a summary of the spaces in the diagram. And very accurately, it comes back and says there is a living room, there is an owner's suite, there is a garage, and so on with the dimensions. So this can then help you, and you can actually directly export this into Excel. As you can see on the screen, there is a button where if you click there, it will take you to Excel and import this information. So today you can, even through computer vision, understand, or through OCR, understand a drawing and summarize it. This could be useful in training. This could be useful in education, maybe not so much for a professional quantity surveyor, but you can see the point. It can at least figure out if there are any discrepancies or issues. There are now tools available in your model authoring tool where you can combine ChatGPT, for example, with BIM, and you can say, okay, count the number of columns on level 2, and it's going to go and give you a number. Highlight all the beams in zone A. It can go in and highlight and find all those beams and sort of put them on, respond to that kind of request also. We already know that in site operations and safety, computer vision, a form of AI, is being used. So you can now detect through video and photographic record if any unsafe behavior is taking place on the construction site. Huge help for site operations and safety. You can identify things like rebar. You can identify people through that image processing. And again, you can think of amazing set of use cases there as well. You can pretty much automate a construction site. This is an example where there are sensors that are being embedded in the concrete, in the tower crane, and other variable computer sensors on construction workers, and AI is helping you create a dashboard where you can see things like maybe noise control, dust control, concrete strength and maturity on a dashboard, again using AI and data analytics. So those were very quick, dirty overview of some of the use cases or applications. Let me close by giving you some of my views on benefits and challenges. So AI is going to be, I think, very helpful. I don't see AI for the time being replacing whole roles or jobs, but it'll definitely help assist, improve our work as quantity surveyors, perhaps as construction managers. It'll help improve operational analysis, operational efficiencies through data and trend analysis. We'll enhance health, safety, and well-being on construction sites. It'll help in cost and waste reduction, increased cost and schedule certainty. Quality can be improved, and most importantly, it can help improve environmental sustainability through prudent material selection or substitution, through careful and analysis of carbon footprint, especially embodied carbon, and so on. But still, many challenges remain. I'm sure you all have heard of hallucinations, wrong data, wrong information, cooked up information created by ChatGPT. Many people are concerned about security of the company data because these large language models basically go and crawl and gather all the web-based information and put that in a common pool. Some of us may still be limited in our skills in the use of AI. The changes that are happening are very fast-paced, and this is still an untested technology. So those are some of the challenges that you may come across when you're using AI. Now, very crucial to application of AI in our domain is going to be data management. and analysis. So we have to be mindful that our domain is going to have both structured and unstructured data. How do we use that in the context of AI? There's going to be, therefore, a very important role of data standards and schemas that we would have to use in order to make sense of all that data. If we have to move towards AI to some extent, we got to be open to data sharing also. There is a huge challenge in our sector of what's called dark data. By many estimates, about 90% of the data that we have on construction projects is never reused. So that's called dark data. We got to think about how we can carefully apply and use that data in our project management, in quantity surveying, and so on. Lastly, I think we shouldn't forget that AI is only a tool in our toolkit. There are other tools, BIM, Common Data Environment, digital twins, and so on, that are going to still remain relevant and important. So therefore, we need to take on an integrated view using the concept of a golden thread. So in conclusion, let me just quickly share with you some future trends and developments that we all need to watch for. As we move forward in the application of AI, we need to address IP, privacy, and security issues. We need to be very careful about the ethical use of AI by removing perhaps biases from large language models. We need to also start thinking about using not the generic large language models, but use those as foundational models and then build on top of them fine-tuned models with more construction-specific data sets and training or fine-tuning. We need to very carefully think of developing use cases and create value. Right now, AI looks like a hammer looking for a nail. Everyone and everybody wants to build something in AI and apply it to construction. But we need to carefully analyze the benefits and the value creation. Nevertheless, I think this is a field that we cannot avoid. It's not AI or no AI. This is coming, this is here. So developing skills and competencies is important also. Ultimately, we'll have to focus on data and information management in our domain, and also work through some of the contractual and cultural issues, mindset issues. Change is difficult. How do we apply these tools? But I'm seeing more and more construction companies, especially in US, Canada, UK, Europe, very open to applying artificial intelligence on construction projects by creating some use cases and by creating value as we develop more and more in this field. So with that, I'm going to conclude. Thank you very much for listening. You have my email here in case I can provide any further information. Please feel free to reach out to me.
Thanks a million, Anil. That was fantastic. Dark data in construction, I can't believe that. And but we're good. What I would say to people online as well is that we do have a questions facility, and we'll have a Q&A session at the end of this webinar after our speakers. So do add any questions that you might have for Anil and the others. Thanks, Anil. I'll just put you, I'll change the details now. And next up, we're going to have Abdul Majid Mahamadou, and he's going to speak. Let me just get my details back up online on harnessing AI for infrastructure project cost benchmarking and ICMS use case. So as Anil said, going a bit more into the detail of AI usage and specific case study issues. So I'm just going to make Abdul Majid the presenter.
Okay. Okay. Thank you very much.
There you go. We can see the slides. Fantastic. I'll go offline. Okay.
Okay, fantastic. So can you confirm if you can see my slide? Okay. All right. So can I start, James?
Off you go.
Okay, all right. Thank you very much. Okay. Hello to everyone that has joined this webinar. So my name is Abdul Majid Mohammadou. So I'm going to be giving the second talk that sort of builds on what Anil has just presented. So and Anil gave the general overview and also, you know, proposed that there's a need for tailored approaches to developing AI for specific construction scenarios. So I happen to have a particular use case in construction that I would want to, you know, share with you. It's something that we developed from a recent project. So I'll give you a bit of details about the project as well as I go along in my presentation. So I work for the University College London at the Bartlett School of Sustainable Construction. And I also happen to be a member of CASLE and a member of the Management Task Force. So in this presentation, I'll be talking about how AI can be harnessed specifically for cost benchmarking. So more on the QS side, and in this particular use case, we attempted using AI for classifying construction cost data based on the International Cost Management Standard. So a bit of background about the project. So the project was called the TIES Living Lab project. So this was sponsored by the UK Department for Transport and the UK's research funding body called the Innovate UK. So this project ran between 2019 and 2022. And the broad aim of the project was to leverage data, standardization, and technology to deliver efficiency in the way transport infrastructure projects are delivered in the UK. And this was with the backdrop that the UK government has a pipeline planned for development of transport infrastructure around about maybe 50 to 60 billion per year over the next decade. And so there are a number of efforts being put together to develop systems that would help the delivery of these projects in an efficient way. So in this particular project, we had partners, over 25 partners who came together to develop various solutions around the use of either data or standardization in improving efficiency within the transport sector. And in our particular case, we used data, or we developed AI tools that could be used in improving the way data is used, specifically for costing or benchmarking within the transport sector. So what was the problem? What problem did we try to solve? So it's good, Anil mentioned dark data within construction. So what we realized is that there is a lot of dark data. So there's a lot of historical data with a lot of insight in it. But unfortunately, within construction, it's difficult to leverage this data to get the relevant insight for future projects for a number of reasons, because the data is either in a very bad structure or in a very bad quality, which makes it difficult for us to leverage it. Another problem is that there's so many different ways in which data is presented across different organizations, different sectors. And for instance, if you look at the project that we did, two organizations that were involved in the UK context was Network Rail and National Highways. So Network Rail looks at rail infrastructure and its management within the UK, whereas Highways England looks after road infrastructure. So they have quite similar assets. So a typical example, like in the picture, is a footbridge. So Network Rail does deliver footbridges, Highways England does deliver footbridges. So in essence, they are the same. However, the way information is presented for the same asset type is different across two organizations, albeit they are both in the same sector, transport. So for instance, Network Rail has its own, follows different standards, such as the RMM, whereas Highways England follows its own internal standards, which are have been inspired by standards such as the CSMM in presenting cost data about their assets. So because of these structural incompatibilities, it's difficult to do benchmarking. So despite the fact that you might be talking about the same types of assets, so you cannot compare like for like, you cannot directly compare how much concrete costs, for instance, in one organization to the other for the purposes of delivering efficiency. So these are the challenges that we noticed within the sector, but broadly it's challenges that have been recognized as well within the QSN fraternity. So what did we seek to do? We sought to provide a system that could help benchmarking across different organizations in this sector. And what we realized was that with all of the dark data that exists and the structural incompatibilities, it took a lot of time for individual experts to actually look at documents and try to analyze them in a way that they could be used for comparisons or benchmarking. So what was the solution we tried to propose? So first of all, we looked out for a solution that is emerging within industry, which is the development of the ICMS, so International Cost Management Standards. So for a lot of you are in the in surveying, so most likely you would have heard about ICMS. So basically, the ICMS has been developed by International Cost Management Coalition, a coalition of about 49 professional and non-profit institutions. And broadly, it's enabling the ability to classify costs across the whole project life cycle, eliminating inconsistencies and discrepancies in the way it's reported across different sectors and organizations. So it essentially provides a framework for translating costs from different standards. So what we sought to do was we tried to see if within the UK infrastructure sector, we could find a means of translating the way cost is presented using ICMS as the translation standard. And obviously to be able to compare not only the same assets, but also to be able to compare across different asset types. So our test bed was UK National Highways. So the UK National Highways has their own internal cost breakdown structure, which they call the WBS, interestingly. And they are one of the early adopters of ICMS as an approach to presenting their data. So they've got the internal standard, but they have an ability of translating their internal standard into ICMS so they can compare themselves to other organizations. So luckily, they have a few projects where they have attempted to do this classification. And so this is the process. So for the assets, they'll usually use their internal standard WBS to present this in cost analysis forms and the like, which they can use for future benchmarking. And what we tried to do was to help in doing this translation, not manually. So currently they do it manually. So if you look at a typical project, that would have thousands of cost descriptions just for one project within Highways England. It will take quite a long time for an individual surveyor to actually do the translation from WBS to ICMS. So what we sought to do was actually to bring in AI to do the translation, so to be able to read the text in WBS and convert this to an ICMS structure to help with speed, being able to do it quicker, having more consistency, or just aiding the surveyors who would have done it manually to be able to do it quicker. This is an example of the cost, the breakdown structure for the standard that we looked at that National Highways uses in the UK. And this is the ICMS categories, level 3 categories, as an example of what we were trying to do. So for instance, if you pick this particular cost item, which belongs to this particular code, so it's a regulating cost, open graded, Makerere, it fits within a particular cost description within the ICMS. So normally, as an individual, you'd read this particular one and try to allocate a cost category within ICMS. But what we sought to do was to automate this process so that the machine can read this description and be able to allocate it to an ICMS category. So this was the pipeline that we followed. So we developed an automated approach for extracting raw cost data from various document formats, either Excel sheets or PDFs. And then we aggregated this into a database. In this case, we use CSV files, and then we then applied the natural language processing classification models in learning. So this extraction would then be manually classified according to ICMS, and then would then apply natural language processing to look at how it's been manually classified by experts, so that it can be able to classify it on its own, even if an expert hasn't classified it previously. So that was the pipeline we followed. So a little bit about natural language processing. A lot of it came up in Anil's presentation, but basically it's the application of computational techniques to the analysis and synthesis of natural language, so including speech, text, and the like. And it's a branch of AI that allows machines to be able to read and derive meaning from human language or text. So there's so many applications I'm sure that you've seen in your daily life, from language translation, automatically predictive text in emails, and also even generative AI tools such as ChatGPT are primarily based on natural language processing capabilities. So this is an example. So this cost description for a highway project, or examples of cost description. What natural language processing does essentially to text is converts it to numbers, because computers can understand numbers a lot more easily. The technical terminologies, I'll not get into the details, such as segmentation, tokenization, or stemming, helps the computer to be able to understand context in the text in terms of keywords, words that are not so relevant, configurations of the words, in order to be able to extract feature importance that helps it in making determinations about the data. So in our case, this highway description, from going through the processes, we were able to identify, for instance, feature importance or key text that would help us classify it in one particular cost breakdown, structure category, or the other. Implementation. So we didn't only go through using natural language processing, so we did that in terms of research, had good results, but we also went further to implement it as a tool that could be used. So this example of what the tool looks like, we developed a web-based tool. So in this web-based tool, you could either classify a single cost item or a batch of cost descriptions, which typically you might have in an Excel sheet in a cost document. So this is an example. So you can, if you're using the single classifier, you can cut cost text, you select single classifier, and then you paste this, and then you submit it for our model to analyze it. And then when our model analyzes it, it gives you a result with an ICMS category that they think that cost description belongs to. Another option is that you can download this in any format that you want. And in using the batch classifier, you can upload a file, for instance, a CSV or an Excel file with a series of descriptions. And when you submit this, the natural language processing model would make suggestions as to what ICMS category it thinks that cost belongs to. And again, you can download this as a CSV, so more in the format that we used to within costing. So we use different machine learning techniques to test this approach. The popular ones we used when we did this project was support vector machine, random forest, and gradient boost descendant approach. And we recorded accuracies between 70 to 95% in terms of the ability of the natural language processing or the machine learning models to predict what category that cost description belonged to in terms of an ICMS. We didn't only stop there, but we also used human validation. Yeah, so we got 3 expert reviewers to look at how the machine has classified the cost descriptions to see if they agreed. The interesting thing is they agreed as much with the machine as they agreed with each other. So sometimes they disagreed with each other and sometimes they disagreed with the machine. So what this says is that the machine was performing probably nearly as well as the human experts were performing. But it also highlights the fact that in this domain, there's a lot of subjectivity. So there's several cost descriptions that different experts will disagree on in terms of where it actually belongs. So this is an example of what it shows. This matrix shows that reviewer 1, for instance, agreed with the machine learning model 74% of the time, reviewer 2, 80%, reviewer 3, 76%, And you can see reviewer 1 agreed with reviewer 2 85%, but with reviewer 3 only 66% of the time. So this is the nature. So from this, it means the natural language processing model isn't performing as badly, because even the human beings disagreed with each other some of the time. I did an experiment. So when we did this, ChatGPT hadn't become so much of a sensation. So it didn't exist at that point. So we didn't use ChatGPT or some of the new emerging models, transformer category models. We didn't use that at the time we did this study, although I've used it subsequently and have some results, but maybe not in the scope of this project. So of this presentation, so I wouldn't be talking too much about that. But in the context of this project, we didn't use ChatGPT. But today, just before the webinar, what I did was to experiment to see whether or not ChatGPT had any idea about how to classify cost descriptions according to ICMS. And this is first of all, I asked it if it knew about ICMS. I used ChatGPT 3.5 because I've not subscribed to the higher version, and unfortunately it didn't have a very good answer. It didn't really know ICMS exists. But I went further also to ask if it could classify a piece of text. So waterproofing with mastic asphalt. I wanted to know if it could classify it according to ICMS. And interestingly, what ChatGPT told me was that the text for waterproofing does not fit into any specific category of ICMS. So again, it raises a bit of the issues that Anil in his presentation raised about AI and some of the challenges that are associated with it. So given the fact that ChatGPT probably hasn't been trained with this kind of data, it struggled to provide any meaningful results. But in our case, we developed our own models using some fundamental machine learning predictive techniques, and our results were promising. So like I said, we've started playing with transformer category models such as ChatGPT, and the results are generally better than what we got previously. At some stage when we have concluded with some of those projects, I'm sure we'll be in a position to share in another presentation. So in terms of a summary, I would say our use case produced some promising results in terms of the capabilities of AI in the space of surveying, specifically cost planning and benchmarking. Although we did face significant amount of challenges, including data quality, data quantity challenges as well, and also simply availability of data. So back to the dark data issue, there's a lot of data that existed in different organizations we worked with, but because previously there hadn't been any plans to work with that data in the context of ICMS, they hadn't categorized it, and that was more challenging to work with. But however, where we had the opportunity, for instance, from the National Highways Organization in the UK, where they had data which they had previously worked on, it made it easy for us to do these experiments. Also, the lack of skills is still a major issue. We were privileged to be funded by Innovate UK and Department for Transport to do this, but not all organizations, across the world might have similar opportunities or R&D funding availability to try out these. Also, we realized that there's subjectivity in interpretation even for humans, and so far as machines, AI works better based on how they learn from others. If they're learning from humans, then your guess is as good as mine in terms of how subjectivity might also be in some of the responses that you would get from AI. And also from a costing perspective, what we realized was there's too much incompatibility in terms of cost breakdown structure for different standards or for just the different ways different organizations work, and that also posed a bit of a challenge in terms of the usefulness of the exercise that we undertook. And also there isn't that much widespread use of ICMS, specifically in the context of the work we did. So there weren't so many organizations that were mature enough for us to be able to engage with this type of exercise with. And I think so that brings me to the end of my presentation. So like I said, this has just been a use case of a project that we've done, and just me sharing some of our results and findings and some of my views on AI, its challenges, or some of the benefits that you could derive from it, specifically in the context of cost planning and benchmarking. So thank you very much, and back to you, James.
Okay, thanks a lot, Abdul Majid. Fantastic. Wow, I can't believe that the QSs argue themselves more than the AI system at the end.
that was interesting.
QSs,
I wouldn't say I was too surprised, but yeah, that was an interesting finding.
Very interesting finding indeed.
Yeah.
That's really wonderful, and a great insight, I think, a bit more in depth on the realities of AI use in specific case studies. And now we're going to move on to our next speaker, Patrick Manu. I'm just going to remove you, Abdul Majid, and add Patrick as the presenter. Oops. Now, Patrick, you're still on mute? Okay, we've got you. Okay, if you could put your microphone on. Yeah, that's great. Okay, you're off. Thank you, Patrick. You're next.
Okay, so can you hear me?
Yes, we can hear you, see your slides. It's all good to go.
Okay, thanks. I think I need to move things. Okay, a couple of things. Okay. Okay, just give me a second. Okay, so James, can you still hear me?
Yeah, we can hear you.
Yeah.
It's fine.
Okay. Okay. So yeah, thanks very much, James, and thanks to the previous presenters and to our audience at the conference. So I'm Professor Patrick Manu. I'm an academic at the University of the West of England, and for my presentation, I'll be talking about occupational safety and health within the construction industry and how that it intersects or interacts or confluences with a broader area called Industry 4.0, of which AI is an important part. Okay, and so the title of my presentation is Confluence of Construction, Occupational Safety and Health and Industry 4.0, Present Status and Future Directions. Okay, but I'll give some background to this presentation, and then I'll jump into what I want to talk about. Okay. Okay. So give me a second. Okay. Yeah. So as a bit of a background, so what I'm about to talk to you about is a study that I did with a team at the University of Melbourne and then University of Manchester, and so I felt it's important to acknowledge, the contribution of these colleagues who made an input to what I'm about to talk to you today. Okay, and so as a bit of a background, so I guess most of you are aware that the industry within which we work, construction, is one of the most hazardous industries worldwide. So here are some figures from the International Labour Organization saying that the industry accounts for over 100,000 fatalities every year, which is about 30% of all occupational fatalities worldwide. And when we look at breakdown based on emerging economies or developing countries versus the industrialized countries, we realize that things are worse when we look at the situation within the developing or the emerging economies. Nonetheless, whether developing or advanced, the industry still accounts for several injuries, deaths and illnesses globally. And I have some numbers from the UK in terms of the economic cost, imposed by these, adverse consequences, that, arise within the industry. So, for example, the health and safety executive within the UK, they estimated that injuries and illnesses resulting from construction, they account for over £1 billion, every year, which is, quite huge. If we put that into context, for example, the London 2012 Olympic Stadium, it cost about £500 million. And so that means that, we can get about 2 of that stadia every year if we are able to, solve the problem of injuries and illnesses, resulting from construction. And so clearly, health and safety is a massive problem, within the construction industry, resulting in huge economic cost aside, the other costs, associated with the injuries and the illnesses. And so clearly, there is a need for improvement to be done. And so as part of efforts to drive improvement within the industry, there has been some interest in this area of Industry 4.0, which broadly describes, trend towards digitalization and automation of industrial processes. Okay, and so some people believe that, Industry 4.0, which covers a broad area, I'll talk about that in my next slide, it can be helpful to address the problems we have. So with regard to safety and health within the construction industry. Okay, and so what we were interested in for our piece of work was to explore this area of the confluence between Industry 4 and safety and health within construction. And in terms of the area of Industry 4, so there are several technologies or trends that makes up this area. And I've taken this table from one of Anil's books. So Anil has led the publication of one of the important materials in this area of Industry 4, and the slide shows several of the technologies that fall under this broad area. Okay, and so we see that things like artificial intelligence is one of the key parts of it, but there are other things that come together to form this broad area. And so as researchers, our interest was to understand the state of application of these technologies for safety and health management within construction. It was to be able to understand what challenges there are so far as the use of these technologies for safety and health in construction is concerned, and then be able to go beyond that to be able to offer some directions or suggestions, okay, for future in terms of things that can be done to drive safety and health improvements further via the use of these technologies. Okay, and so for the work that we did, clearly it's a very broad area, and it was going to take a very long time for us to do it, but we had just 1 year to do this piece of work. And so we decided to do what we call a parallel systematic reviews, and parallel in the sense that the team in the UK chose to focus on some aspects of the broad area of Industry 4, and the team in Australia are focused on some of the parts. For the purpose of this presentation, I'm not going to cover all of them. I just picked 4 of these areas, including artificial intelligence, which is the main thrust of this whole session. Okay. So what we did was, given that we had a very limited amount of time, we had just 12 months to do this piece of work, we chose one literature database which is called Scopus to help us do that piece of work. And then we had 3 main groups of keywords to help us get the relevant materials that we needed to be able to address those objectives I showed on the previous slide. So keywords covering the technologies, keywords covering the sector, construction, and then various keywords or iterations of keywords that cover the broad area of safety and health. Okay, and again, we applied some criteria, to pull together very relevant and very authoritative materials. For example, we were interested in articles that are published in journals only. We're interested in articles published in English, and then we were concerned, as at the time we did the search, we limited the search period from the start of the database to the first quarter of 2021. Okay, and then when analyzing the papers that we got, we're interested in some of these things in terms of the year of publication. Which parts of the world have these studies been done? Which issues or areas of health and safety have the technologies been applied? Which types of occupational safety and health hazards have the technologies been applied, to address? What outcomes, have emerged out of that? Which stage of a construction project, those technologies were applied to address safety and health issues, and so on and so forth. And certainly we were interested in limitations and challenges as well. Okay, so quickly I'll touch on the first one, which is the area of automation, robotics. So that one we got a little over 150 articles after the search that we did, and here are some of the results we got, from the review. So from the review, we observed that there is a growing interest as far as research is concerned within this area, particularly from the 2015, coming all the way to 2021. We see that there is a rapid growth of research within this area, which tells us that it's an area that is worth exploring or worth looking into, given that there's a lot of interest in this area. And then in terms of the spread, the geographical spread of where those studies are being done, we were not surprised to find that a lot of there's a massive concentration of work in some parts of the world. So for example, in the US, there's a lot of research concentration in that area. When you go to Asia, countries like South Korea are also very heavily involved in looking into this area of robotics automation for safety and health issues in construction. And then in terms of what issues or areas these technologies have been applied to address, several of them covering risk and hazard prevention, safety monitoring, training and education, so on and so forth. But in terms of the specific hazards, we realized that primarily they focus on addressing safety hazards. And so that got us thinking as to why that is the case, with regards to the broad area of safety, and also why the greater emphasis on safety, but we see that there is limited interest or research when it comes to addressing health issues within construction. Again, in terms of the types of outcomes, so addressed by the technology, so several of them, so they have been applied to address things like MSDs, low back pain, and several other things. But for some of the studies, they weren't specific as to which safety and health risk or outcome the technology was applied to address. In terms of the stage of the construction that the technology was applied, we realized that there's a massive concentration on the construction phase, which makes sense because that's where the problems arise. However, there's a risk that we lose the opportunity to be able to address these issues early in the planning and design phases, before construction actually starts, because studies have shown that the design and planning phases offers as the best opportunity or the best chance to be able to improve things like safety and health, sustainability, and other things like cost, as Abdul talked about previously. And so we realize that there is limited attention on the construction phase of projects. And then in terms of hierarchy of control, it's been mainly applied, to eliminate hazards, but also other things like reduce them, control them, and so on and so forth. So that's quickly about the robotics. So some of the challenges are the high investment cost needed to implement or incorporate some of these, and also some of the other challenges are the fact that construction is dynamic, unstructured, and so it's difficult, applying some of these technologies there. But interestingly, we and this ties in with some of the things Abdul and Anil said. We realized that so this technology is not being used in isolation, given that the area of Industry 4 is more about how these technologies work in consonance with other technologies, for the benefit of things like productivity and so on and so forth. So realize that it's been applied, in conjunction with other technologies within the space. So now let me quickly move on to another one, which is wearable sensors. Again, we observed a similar trend, a growing interest in this area, as shown by the slide. In terms of areas of concentration, once again, areas like the US, South Korea, but more broadly, the global north. When it comes to countries in the global south, there's very little that is happening there, so far as research is in this area is concerned. In terms of the areas of health and safety addressed, similar to the robotics and automation, so things like training and education and so on and so forth, as you can see on the screen. But also it's worth mentioning things like health monitoring, people wearing some of these sensors, to monitor things like whether they are dangerous, or hazardous gases around them, just to pick data from the environment, that will be very useful so far as safety and health is concerned. And in terms of the hazards, so over here we see that there is sort of almost the same interest in safety as well as health hazards. And in terms of the outcomes addressed, primarily they've been applied to address musculoskeletal disorders within the industry. But once again, massive concentration on the construction phase, but with little being done at the pre-construction phase, which can be very useful eventually to address health and safety problems during the construction phase. Hierarchy of control, primarily the aim has been to reduce the hazards rather than trying to eliminate the hazards. And we found similar challenges. So some of the challenges are most of the works that have been done, they've mainly been deployed in lab settings or lab environments, and so there's whether or not these things are truly helpful or beneficial. There's still some debate in this area, given that the construction environment cannot be entirely likened to things that occur in the lab. And again, we saw that there is the use of limited samples and limited studies that apply those technologies in real construction sites. Okay, so quickly, another area too that we looked at is AR, VR, mixed reality. So similar trend, growing interest in this area. In terms of the geographical spread of research, once again, it's the US. And again, when it comes to countries in the global south, there's very little being done as far as research in this area is concerned. In terms of the issues, so similar issues or similar areas, as I mentioned in the previous slides. In terms of the hazards, so these ones have primarily focused on safety hazards, primarily in terms of prevention of fall. So people, using these VR or mixed reality headsets as part of, training, to help workers, prevent, the risk or the likelihood of people falling when on construction sites. But again, in terms of the life cycle stage, heavy focus on construction, pre-construction, very limited interest. Again, with this technology, very limited focus on eliminating the hazards. So we are sort of trying to manage the hazards rather than trying to eliminate them. And again, some of the challenges are limited application on real construction sites, sample sizes that have been used to test these applications. Some of them are small, some of them are students, and so that tells us that there's still more work to be done, to be able to, ascertain, the practical utility, of some of these emerging technologies. And now, finally, jumping to AI. So with this one, we came up, we were able to pick about 60 studies in this area. And when we analyze those studies to, once again, similar trend, there's growing interest in this area. This time, in terms of the concentration of research, we see China and the US, representing, heavily in this area. But once again, in terms of the global south, particularly sub-Saharan Africa, there is limited amount of, research that is going on in this space, so far as safety and health in construction is concerned. In terms of the areas or areas of health and safety issues addressed, similar to some of the ones we've looked before. So things like communication, training and education, and so on and so forth. Just want to go through this quickly. In terms of hazards, so a wide spread of hazards, which this has been applied to try to address some of them being health, some of them being safety specific hazards. In terms of hierarchy of control, there is some interest or some focus on eliminating the hazards, but primarily we see that it's about trying to reduce or trying to contain or manage those hazards rather than a lot of efforts being directed to eliminate the hazards in the first place. As far as the construction phase is concerned, the life cycle, again, predominant focus on the construction phase, limited attention being paid to the design or the planning phases, which gives us opportunity to to address things in the construction phase. In terms of challenges, so similar challenges, most studies were conducted using smaller number of participants, or maybe they haven't been really deployed on construction on real sites scenarios to be able to test the scale utility of some of these technologies. And so just to round up, so these are some of the major conclusions we came up with to shape directions for further work that can be done within this area to be able to hopefully improve safety and health within construction. So some of the conclusions are, so clearly there's a growing interest in this area of applying emerging technologies such as AI and the rest under the broad umbrella of Industry 4 and safety and health is a growing area. There's a lot of interest in this area, but we see some countries dominate, for example, US and China, or generally, countries, within the, the global north. But when it comes to countries in the global south, particularly sub-Saharan Africa, there's a lot of opportunity for works or for studies, for similar studies to be done, to ascertain, the practical benefits or utility that it can be derived, from these technologies, given that construction practices, are not the same everywhere. So there's also the need, to look at that in this domain. And again, as I mentioned before, there's a dominant focus on construction phase, which makes sense because that is where the hazards they manifest. But we know that, as I said before, the design and planning phases offers us the best chance to be able to address some of these issues. And so perhaps we should begin to look at how these technologies can be applied earlier on before construction to be able to deal with safety and health problems, so that we don't see a lot of them during the construction phases of projects. And so I think I've made that point already. And again, we saw a dominant focus on occupational safety. In other words, how to protect people from physical injury. Okay, but we've come to realize that that health issues, including mental health issues, are also very important within the construction industry. The health issues, they take longer for them to manifest. Okay, so in terms of, should I say, latency, they aren't immediate, and so there's a risk or tendency for people to focus on the immediate ones, which are the safety ones. But there is a need for us to explore how these technologies can also be used to address occupational health issues within construction. And again, to address the issues about the extent to which these can be very helpful in addressing safety issues in construction. There's a need, for more, real life, case studies where we test, these applications, rather than, just, testing them, in laboratories, or testing them using, non-construction, or non-industry personnel. Okay, and again, there's a need to look at what we call potential unintended consequences, because I think Anil and Abdul talked about issues around ethics, privacy, and so on and so forth. So whilst these technologies can be helpful, and we are seeing that there is some utility based on applications in other sectors as well, but we should be mindful that sometimes applying new things can backfire in terms of triggering things that we were not expecting to have as a result of those new technologies. So there's a need to look at them very well. So not just embrace them, but whilst embracing them, we need to be mindful of what are some of the potential unintended consequences, safety and health-wise, which can arise from these technologies. And also, there's a need to explore, interrogate their acceptance amongst the workforce. Sometimes things can be introduced within the workforce, but the workforce may not be ready to accept the usage of some of these new technologies. And so there's a need to also explore their acceptance within the construction workforce, because if they don't accept them, they wouldn't use them, or they might misuse them. So that brings me to the end of my presentation. And on the back of that piece of work that I've just presented, so myself and Anil and a team at Manchester and University of Melbourne, so we produced this book, which covers the broad area of Industry 4, of which AI is a part of, and then how they confluence with safety and health and well-being issues within the construction industry. And so if you want to know more about this area, you could get a copy of this book or other materials that also covers this area. So that brings me to the end of my presentation. Thank you very much for listening.
Many thanks, Patrick. That was really fantastic, incredibly interesting, particularly the wearable technology and augmented reality, the tech that we're seeing being used all across construction and other sectors of surveying as well. Okay, we have our last speaker who's going to kind of tie things up for us and speak about AI in a broad sense of cross-land and property. That's Andrew Knight, the head of technology at RICS. I'm just going to make him the presenter. Cool.
Thanks, James. Can you hear me all right?
We can hear you. Are you ready to go, Andrew?
I'm indeed. Let me share my presentation.
Yes, there we go. Okay, I'll get offline and leave you to it.
Right, hopefully you can see my presentation now, James.
Yes, all good.
Good
Fantastic.
stuff.
Thanks.
Well, thanks everyone for the invitation to present this afternoon. It's a real privilege. By way of an introduction, thanks James. I lead our work at RICS looking at the broad application of data and technology, and obviously increasingly AI, right across the property life cycle. So thanks to my co-presenters this afternoon, and I think as James alluded, what I'd like to do is take a view really right across the property life cycle in terms of data and tech and AI, and have some thoughts about what that means for us in terms of peoples and roles and training and evolution. I have a very privileged role here at RICS because, as well as leading our thought leadership work on this subject, I also run a global community of data and tech firms who produce solutions that are affecting the built and natural environment right across that life cycle. Many are based in the UK, reflecting our UK heritage as a professional body, excuse me, but we also have many firms operating right around the world, right across that property life cycle, across all the different asset types. So it does give me great insight into actually what is already being used, is already being adopted, some of the challenges around that, and indeed the very pervasive nature of the various flavors of artificial intelligence that are now actually being implemented in those solutions as well. So what I want to do first was kind of almost go through that property life cycle and just talk about a few examples of this very, very pervasive adoption now of data and technology. And as you all know, this is being led by both a very healthy ecosystem of startup firms, but also very well-established firms that have been producing tech solutions for many, many years across the sector. So a lot has been spoken about already this afternoon on construction, but it's worth just reviewing the kind of areas where we're seeing data and technology being used. And one area I'd highlight is a number of solutions I've seen being adopted and used where the kind of quantity takeoff process, the bill of materials, bill of quants, it is being automated and also being supported by AI. And I think it's important to get across the fact that so often now what I'm seeing is not so much AI as 100% solution to fulfill a particular role, a particular solution for a practice area, but as part of that overall solution. So you're seeing AI being used as a part of the toolkit when people are building solutions. And in the case of quantity takeoff, I've seen AI being implemented essentially to help the quantity surveyor take those quantities off, not totally automate the role, but help them in terms of prompting, in terms of giving suggestions. So a lot of areas where, once again, we're seeing it in construction, and that quantity takeoff, I think, is quite a good example there. We're also seeing it in the use of drones increasingly in the construction phase. I think people quite often associate drones with more around building surveying, but a lot of people using it specifically in that construction phase to look at the site, to manage changes of that site, using AI to improve the interpretation of the images that are being gathered, to actually control the flight path, have intelligent collision detection when those drones are flying around, and indeed then to actually calculate quantities when they're looking at spoil heaps or holes, you know, at the topography of the actual construction site itself. So a lot of effect we're seeing on the construction side. If we look around the valuation piece, once we built these assets, clearly a huge amount of work has been taking place in automated valuation models, particularly in residential with developed markets where we have good quality data, where we're seeing a really kind of powerful automated valuation that's driving a lot of lending and valuation, particularly in the residential space. But we are seeing people beginning to look at commercial non-domestic assets as well. And I think it's worth highlighting, I think, for commercial real estate, that whilst it may not be able to be automated using AI in quite the same way that's happening for residential, we are seeing mass appraisal bodies for property taxation purposes, using it for both domestic and non-domestic properties. And indeed, many people beginning to look at how excuse me, it can be applied to commercial real estate, even if it's around finding perhaps comparable properties that wouldn't normally be generated by a human valuer, by looking at different cities that have similar characteristics that can give you that comparable property, where with commercial real estate, you obviously have always challenges of finding suitable comparable properties for comparable evidence. And in many cases, excuse me, it's being used for the appraisal part of valuation, where you're looking at viability and looking at the actual, excuse me, while I just grab a drink of water here. as I say, increasingly it's being used for very complex appraisal projects, looking at econometric data, demographic data, as well as the actual directly related property data to do quite complex data analytics and modeling to understand the viability of different kinds of projects on different kinds of asset types. So a lot of work going on in this sort of data analysis valuation space. And in many cases, that's AI helping either as a data science piece or as a direct kind of black box approach in terms of those residential valuations. So if we look around transactions, we're already seeing a lot of use here of AI in terms of data and technology, in terms of generating data and data rooms. And I think it's probably been a point that's already been made by some of the other speakers in terms of AI being a very, very powerful tool to turn unstructured documents into structured data. That natural language processing, that ability to turn so much of the property data that we currently have, which is held in these kind of digital but soft copy type formats, whether it's a PDF or a Word document, there's already a lot of adoption of actually using that technology to actually turn these rent roll data, these other pieces of information on land and property into more structured data that can then be analysed. And so whilst the sector is very challenged by the lack of structured information, AI is proving to be a very powerful tool to actually help us turn that unstructured information into data that then be analysed in that way. So it's part of the solution. If we look at the occupational side, already a huge amount of adoption in the fairly prosaic but very important area of building management. One example where it's already delivering a hugely powerful return on investment is something as simple as really the management of HVAC, heating, ventilation and air conditioning units, where in buildings they represent a very large percentage of the power requirement for a building, and typically there are huge savings to be made by an ongoing machine learning type approach to monitoring those VAC systems, having sensors, getting to feed back to a relatively, in AI terms, straightforward piece of machine learning to really optimize how those HVAC systems are used, taking advantage of the ability to predict and monitor the occupation of different parts of buildings, the actual temperatures, etc. And so that's an area where we're already seeing a lot of very, very powerful return on investment by using AI to monitor these buildings. And I think a point that should be made a lot about these smart buildings is, as we increasingly put sensors, the Internet of Things into these buildings, we do have huge amounts of data coming in, that classic big data issue of volume, variety, where you almost need by default some kind of AI to actually process that data, where it's coming in huge volumes very quickly, and it's coming in a huge variety. Some of that may be obviously reading from machines, some of it may be visual content from CCTV, other kind of sensors. And so you really do have a very, very big challenge there with large buildings and complex sensors to make sense of that information and turn that data into actionable information to make sure you can actually run that building more efficiently. But once again, really already an area where AI is really having a profound and powerful effect in terms of that net zero energy saving kind of agenda. So artificial intelligence, what do we mean? I'm conscious my fellow presenters have already given some definitions, but I would like to kind of really go very high level here and always make the point that this is a simulation of human intelligence before we get too far ahead of ourselves, that these are machines and algorithms that are designed to mimic cognitive functions. And although it does have the potential to automate very, very many tasks, we do also need to understand its limitations and some of the kind of restrictions and governance issues that have probably been mentioned already here already this afternoon. And I think I'd like to reinforce that point that AI is already here and not always visible. It has become very pervasive in many of the firms I work with and is not always visible. I did this presentation to a group of people in a London venue a few weeks ago, And one of the questions I've asked of the audience, who are made up of major property firms, major consultancies, about whether they're already using AI, and I'm very suspicious about how many said they weren't, because I think in many cases organizations are already using AI, even though they don't recognize it. It's quite often embedded in the solutions they're already using. Either that, if they're a large company, they may find that other parts of the organization are using AI already and they don't really realize. So it has become very, very pervasive, despite all the recent rhetoric and excitement over the generative AI. The more predictive AI that's been out there a long time is really, really very, very pervasive now. We've talked about all the various methodologies or all the different versions of AI, I know in my previous speakers, but I'd just like to make a point perhaps that sometimes people do perhaps big up, to use the vernacular, or perhaps exaggerate what they're actually using and calling it AI. Many moons ago, many years ago, I worked in a firm where we were looking at consumer data, and we were using very complex statistical modeling. And in many cases, a lot of AI is really actually sophisticated but powerful regression analysis, etc. But nowadays we perhaps do refer to that as AI, even though arguably it's been around a long time and is really just statistical modeling, looking at data sets. But obviously we do now have, as we all know, these various flavors of machine learning, deep learning neural networks, particularly neural networks for facial recognition and other kind of recognition type applications. And as we all know, these various flavors now of foundation models that have given us generative AI, and whilst we get obviously very, very a lot of knowledge and a lot of talk about the text type models like ChatGPT and the other ones that are available, but also the various image-based and video-based and design-based generative AI, where, for example, I've seen people using those tools to generate garden designs for landscape architecture. So a lot of people using these generative products not only for text, but for also images, videos, and designs. And as probably been touched on earlier, there are some issues, particularly with things like ChatGPT and these other tools, when we think about the fact that they produce hallucinations or typically simply erroneous results on certain occasions, and issues around IP and copyright. We have to think about these tools even if we use them purely internally. If we think about some of the natural information barriers within an organization around non-disclosure agreements, commercial terms, we have to be very careful if we're even using these models internally with data to make sure we understand the implications of loading data into these models, where we may be quite understandably working within these commercial terms and restrictions. So we need to be careful that we don't breach these fundamental issues of confidentiality, privacy, and think about the whole governance piece. One thing that I think is very important whenever you look at AI, particularly as you go up the risk pyramid in terms of the importance of the decisions that AI is taking, is to think about these concepts of explainability and transparency. And perhaps if we think about automated valuation as an example here, we need to be very, very confident that if we're going to use these particular tools where they have an effect on perhaps secured lending or mortgage decisions for individuals or lending or investment purposes, that or indeed property taxation, that we have to have an understanding of not only the overall effectiveness and efficacy of these models, depending on the kind of asset we're looking for to value, the region, the market conditions, the purpose of the valuation, but also that ability to explain itself. Can the model explain its decisions? Now, at one extreme, if we have a machine learning model that's controlling your HVAC, then I think that's relatively low risk in terms of just making sure that it's delivering good results in terms of energy savings and still producing a good environment for the occupants of that building. But if we think of this context of valuation, whether that might be for organizations or for individuals, for taxation, for lending, as I say, we have to be very careful about thinking about, are we able to actually have this model explain its methodology to some degree? Is there some kind of explainability and transparency in terms of how these models have come to decisions? And if we're using these models, I say, particularly to affect lending decisions or consumers, or using them to perhaps monitor a workforce within a building, we do need to think very carefully, not just about the bits and the bytes and the technology, but that whole governance framework and that ability to understand that we're not by accident having bias included inside them. And also we need to think from a surveyor's perspective, if we're going to produce work output, are we thinking about liability here? If we're using these models, where does the liability sit? Who's developed this model? Are we using it from a third party? If so, do they actually carry any liability if, for example, in a valuation example, it produces an incorrect value and there's some demonstrable fault? So we do need to think about the human commercial implications of using these models, particularly as we go up that risk pyramid, as the risks of the output become more and more important and more impactful. Just a slide here where I want to talk about some of the overall kind of challenges that this prop tech ecosystem around the world is facing, because it's a very complex area. For those of you working in firms who are looking to use prop tech, in its general terms, you'll find there's probably something around 18,000 firms out there of various sizes and various maturity, offering services right across this property lifecycle, many of which are using AI. And in many ways, it's been a very kind of bumpy ride. There's a lot of investment, there's a lot of activity, but we're not necessarily seeing adoption really right across the industry in many ways, and it is still challenging in that sense. And in many cases, what we've seen is perhaps people with great technical knowledge building solutions, but lacking that built environment domain knowledge, and really, as the phrase goes there, developing solutions that are looking for a problem. And in many cases, they haven't been able to identify and show a clear return on investment there. And as a result, they've really not been able to scale. We still see many, many small startup firms who are not getting to that size where they can really therefore generate profits, really grow and improve what they're doing. As I said, it is everywhere. AI is having a huge impact. And I, for one, would actually look forward to the day when we don't really need to talk about property technology at all and prop tech, and literally have an industry that is actually developing technology itself, using technology from a mature supply chain, and really that we don't need to use that word anymore. And I think if we're going to fully embrace tech and AI, we do need to make sure that we look at it from a business perspective, that technology itself is not an end in itself, it's only a means to an end. We need to think about solutions having a proper ROI. We need to think about whether we're just digitizing poor processes or whether we should re-engineer some of the processes that we're currently using at all those various parts of the property life cycle. And we obviously do have some challenges around a very fragmented sector itself. As you're all aware, the number of tiers and actors in a construction project, for example, and just some of the challenges around the fact that we do have very differing asset types, very heterogeneous, very different assets, very different processes. And as I mentioned before, AI can be a help here in terms of also really helping with this data poor, unstructured, siloed type of environment we live in, where data is hard to really join together. And I think some of that also comes down to sort of behaviors across the sector to make sure that we do share data, that we not only overcome some of the challenges around the technical ability to share data, given its different formats and its different structures, but also some of the behavioral and commercial issues about being willing to share data, albeit on a governed way, but being able to share data in a more open way, not only perhaps around a construction project, but then on handover and through that asset life to make sure that information on that asset is available and is shared more freely. And certainly, I think we still do see a lack of skills and awareness in certain parts of the sector in terms of what AI and data and tech can actually bring to the sector. So, final thoughts. That top phrase was a phrase that I've heard many people now use, that you won't lose your job to AI, but you might to someone who uses it. I think AI will become even more pervasive, and I think it's an interesting set of questions for the sector to think about. Do we need to become data scientists, or I think, in my view, simply learn to work with them, understand the terminology, the language, work with them when they're developing solutions that will affect the built and natural environment and your role in that property life cycle. And I think very importantly, as surveyors, if we're looking at the output of AI in all its forms as part of our work product, whether that's to clients or internally to other stakeholders, to retain that professional skepticism, to make sure that we are still providing that reasoned advice where we will look at the output of various data and technology and AI tools, but still apply that skepticism and that advice on really what the best solution might be. And I think we've got to learn to use the relevant solutions, be aware of what's out there, and become that intelligent customer that we can ask the right questions, either of our internal teams who are developing solutions, or indeed the supply chain that we're using for any of the tools that we're going to bring on board. And then we do need these high-level understanding of the data governance and ethical dimension. Just because we can do something with AI doesn't mean to say we should do. And clearly there are cybersecurity issues more generally as we digitize the built environment. The more we have smart buildings, the more we turn unstructured, siloed data into data that's shared in a much more accessible way. We clearly have issues there with that data becoming easier potentially to gain access to, where a lot of that data may be very sensitive. So we do need to think about the cybersecurity side, and if we think of IoT and smart buildings, and indeed IoT devices on the construction site, we've got to think about the fact that these are quite often low-tech devices in terms of their inbuilt cybersecurity. So we do need to be very, very careful that we don't leave too many open doors when we digitize the sector in general. And we also got to be able to explain technology to our clients, explain what we're using, be very clear if we are going to use AI where there is a element of risk to some degree, and be very clear about those issues of transparency and being able to explain how AI might be producing some early cost advice or evaluation or some other kind of advice like that. And I think we're going to be very careful about thinking about the next generation. How do we make sure that as these tools continue to improve and support our work, how do we make sure that the next generation are not de-skilled, that they still can have that professional skepticism, that they can still understand from first principles how to take quantities of, how to value an asset, so that they, when they're reviewing the information that comes out from some kind of AI product, that they have that professional skepticism. They can understand when they need to perhaps apply that overlay of experience and knowledge. So I think we need to be very careful that we don't de-skill the next generation, because if we want the next generation of senior partners and directors of our major firms, if they're starting now, how are they going to have that kind of apprenticeship? So a few links there in terms of content from the various partners we work with, a paper specifically about automated valuation, and a survey paper that also talks about the way our PropTech partners see the marketplace in various dimensions. So thanks for your time this afternoon, and hopefully that gave you an overview at a high level of the kind of activity we're seeing and the kind of challenges and opportunities out there.
Many thanks for that, Andrew. That was a fantastic overview, I think, kind of bringing us out of the construction area and looking at AI applications across all of our sectors. And I think you're very, very right to focus on that next generation and their potential, the skill sets that they will need to develop to be able to work within this. We're really quite rapidly evolving and quite quickly evolving world. I know that my youngsters in the house are really getting to grips with this technology quite quickly, as are many students at universities. Long may that continue. Right, we did have a couple of questions, but what I'm going to do, because we're running a bit short of time, is go over to the chair of CASLE, Joseph Ajanlakoko, who's currently in Makerere University in Kampala, and I'm going to try and give him the mic using technology. Let's get his name up. I see him there. Joseph, would you like to say a few words? You can unmic yourself. I'll just give it another minute. We might be having problems connecting. Okay. Well, maybe not. I won't keep everybody hanging around on a Friday afternoon. I'd just like to thank everybody and all of our speakers. There were a couple of questions. We'll get back to those, mainly about intellectual property and the use of those large language models, which is something we all have to think about. And just to finally thank our speakers, and Neil, Abdul Majid, Patrick, and Andrew, of course, and thank all of you online and those of you in Kampala itself, physically at the CASLE ISU conference. I hope that's been a useful session. It's been recorded. We'll make the recording available to all CASLE and ISU and of course our ICS members after we're done. Okay, it just remains to say thank you for joining in, and we'll see you again soon.